Dear children, this is teacher Geeta. This is grade 11 physics topic oscillation. It's a revision topic. I'm going to give a short explanation about this one. You know that what are oscillations? You know that some movements involve repetitive to and fro motion. Examples, we can say that the pendulum, the movement of a pendulum, the beating of heart, our heartbeat, okay? And the motion of a child on a swing, and the vibration of a guitar strings. All these are the examples of oscillations. Oscillation means an object that moves to and fro continuously is said to be an oscillating or vibrating. How can you say that the object is vibrating? An object that moves to and fro continuously, as it is said to be oscillating or vibrating. One complete movement from starting position then down to the final position and back up the starting position is known as an oscillation, one oscillation. Here first we have to link free oscillation. An object which moves to and fro is said to be oscillate, where each to and fro movement complete one cycle of oscillation. The body oscillates with its own natural frequency and under no external influence other than the impulse that initiated the motion. The motion is described as free oscillation. A simple pendulum is an example of a body that undergo free oscillation. We here to see free oscillation, an object oscillates with constant amplitude. The total potential and kinetic energy of the object will remain constant. This occurs when there are no frictional force acting on objects such as air resistance. Now the terms of oscillation and the terms and definitions. Here it is amplitude. Amplitude is defined as the maximum magnitude of the displacement from the equilibrium position. It is measured in meter. The unit is meter. So the time, next one is period. It is defined as the time taken for one cycle, measured in a second. The time taken for one complete oscillation or vibration is referred to as period T. So the number of oscillations or vibrations per second or per cycle we have to say. So the equation T is equal to 1 by F. And the frequency is defined as the number of cycles in 1 second. Amplitude, period and frequency. And the number of oscillations or vibrations per unit time is frequency, and period is the time taken for one complete oscillation is period, and amplitude is the distance from the equilibrium position, okay, or it is defined as the maximum magnitude of the displacement from the equilibrium position. Here it is the equations. You remember that T is equal to 1 by F, period is equal to 1 by F, 1 by frequency. And here you know that the frequency omega, in circular motion we studied that the angular frequency omega is equal to 2 pi F, and here or we have to say F is equal to omega by 2 pi. Okay, this is about simple harmonic free oscillations and simple harmonic oscillation. Now the using graph, how can you explain that simple harmonic motion? The simple harmonic motion means it is defined as, or it is the motion of a particle about a fixed position such that its acceleration a is proportional to its displacement x from a fixed point and is directed towards the point. But this type of oscillations are called the simple harmonic oscillation. But here it is showing the displacement, the graph showing that first one is displacement time graph. But displacement x varies as the cosine or sine. A is the amplitude. So x is equal to a cos omega t. Then velocity v is the gradient of the displacement time graph. It has maximum value a omega. And the next graph showing the acceleration. And here it is the gradient of velocity time graph. It has maximum value of omega squared a. And here acceleration a is equal to minus omega squared x. But this is about the graph of simple harmonic motion. And now the equations. These are all these equations are connected to our circular motion. This simple harmonic motion also related to circular motion, and remember this one, omega, the angular frequency omega is equal to 2 pi by t. T is equal to 1 by f. You have to calculate that omega is equal to 2 pi f. Then a is equal to minus omega square, that acceleration, x0 sin omega t or x0 cos omega t. V is equal to velocity, that is omega x0 cos omega t or minus omega x0 sin omega t. When this is the final equation for velocity, and plus or minus omega root of x0 squared minus x squared. Omega is the angular velocity, t period of motion, x position at a time, and v velocity, and x0 the maximum position, that is amplitude, and v0 maximum velocity. Remember this whole equations, and it's very important. We did already experiment in the lab. I think all of you remember that one. Here it is. I added one video. Watch this carefully and do the worksheet also.